Kim. I'm just going to show you some really scary math to start with. We all know that we have to reduce greenhouse gas emissions by about 90% in the next 30 years. And just to put this in perspective, and that is to keep ourselves below 1.5 degrees of warming. That's a really crazy target. I'm on the City of Edmonton Energy Transition Advisory Committee, and Edmonton will have blown through its carbon budget to stay within 1.5 degrees at the rate we're going in 8 years. If we implement the conservation measures that we have been planning, we can stretch that out to 10. So it's a pretty scary prospect. So buildings are responsible for about 40% of those greenhouse gas emissions. Today, 70 to 80% of the buildings that we'll be using in 2050 are already built. That's totally scary. That means if we don't deal with existing buildings, we're pretty much hooped. We are not passing a livable planet on to our kids, and we haven't even started to do this. So it's a grim and really unavoidable fact at this point. So the Dutch have got, like, a little bit of good news. The Dutch have been thinking about this for longer than we have, and they've developed a pretty cool system. They start with existing buildings. They do a digital scan of it. They build panels in a factory off-site. They're on site for a few weeks, and they've turned these buildings into essentially net zero energy buildings. Zero on the meter, they call it. The roof panels that come in have racking for solar panels. When they're gone, the companies that are doing this leave with a guarantee that the utility bills for that building will be zero, basically for the foreseeable future. And so they've done about 5,000 units, and they've got another 10 underway. Their pilot project is 110,000 units, and then they're planning on millions. So it's really inspiring and hopeful. There are huge advantages of these panelized deep energy retrofits, especially doing it all at once. So it's cheaper in the long run than doing a little bit at a time type renovations. Quite often, if you replace your siding and add 1.5 inches of insulation and don't make the building airtight, don't change your windows at the same time, and really you should have added 3, you're really doing work that would need to be redone to get that building to a carbon neutral ready standard at some point. So it really makes sense to do this all in one shot. It's way less disruptive on the site. You don't have tradesmen coming up 1,000,000 times doing little bits of stuff here and there. You have one big disruption and you're done. And it's cheaper in the long run. So we have gotten funding from National Resources Canada to do this to a 59-unit townhouse complex. They're paying part of the cost, and the co-op whose housing it is are paying the rest. So this is the site. It's a 59-unit townhouse complex built in 1970 in Riverdale. And very handily located. That house with the green roof there is mine, and the house next door to it is the Riverdale Net Zero House, the first net zero project in northern Alberta that we built about 12 years ago. We had some NAIT students come to us doing a Bachelor of Technology degree a few years ago, and they wanted a suggestion for an energy efficiency related capstone project, and I suggested to them they might have a go at the Sundance Housing Co-op and do a feasibility study for a net zero energy retrofit. And they did a great job. They blower door tested a bunch of of houses. They did HOT 2000 modeling on them, and then and got the co-op's interest up. And so they hired Stuart, who you just heard from Renew Engineering, to kind of formalize and professionalize the work that the students had done. And I helped him with the building condition assessment, and he did similar modeling and came up with scenarios that would come to a sort of a carbon neutral ready. And he got Dave Butterwick, who is one of the partners in Butterwick Construction, and now Stuart and my partner in Butterwick Projects, to do the costing on it. And then not much happened with that until we got this opportunity for the R&D funding with Enercan, and we gave Enercan this proposal, and we're really taking the Energiesprong approach and applying it to a fairly difficult site where we're going to have to solve all kinds of problems like that they don't really have in most of the multifamily sites in Holland. We've got all kinds of landscaping. We have to watch out for we're doing this while people are living there, and some of the yards are very nicely done, and somebody's grandmother's petunias are in the way of our panels, and these are all serious matters, and we got fences, we've got sheds in the way, we've got places where concrete is right up against the building, we've got some really tight geometry in some places, cantilevers. And in fact, when I showed the little jog thing to a fellow who gave me a tour in Holland of a couple of Energiesprong installations, he said, "Oh, that would be a no-go." So we've got a real challenge here, and we've got to we got started. So basically, our proposal to Enercan was that we would start with a pilot phase where we retrofitted the first duplex and develop systems to and analyze the mistakes and the learnings from that, and use that to refine the costing before we tackle the other 57 units. So we've done that now, and we're in the phase right now where we're working on our costing on the other 57 units, and mulling over the lessons we've learned and costing out the changes that we're proposing to make. So in a nutshell, the process is that, and we didn't do this in the pilot, we actually used a tape measure and measured the building because we're struggling with the digital capture still, but you use a digital capture that turns into panel drawings, build the panels, prepare the building, swing them in place, and then finish it off. And I think I talked about some of these advantages here. I just kind of like this cool banner that we had made, so I'll skip over that so I don't run out of time. But the digital capture is quite interesting, and it's a critical component of the process. You can't really rely on tape measurements because of the likelihood of error. If you've got a crew of 5 or 6 people and a crane and panels that have siding on them, and you run into a window that's 2 inches off, or you forgot about a vent that you need, something doesn't fit, you're stopped in your tracks, and any of the advantages of panelization kind of go out the window. So we're still working on this. We're working with photogrammetry, and we're also trying LiDAR, and we're making headway on both of those. That's part of what we're doing right now in the interim. We've got to get that going, essentially before the fall. So And then once you have the digital image of the building, it's typically a point cloud. You need to then take dimensions off that point cloud that can turn into a reasonably accurate measurement of the existing building, not necessarily level, square, or plumb. The windows didn't necessarily get put where the plan was exactly. So you need to really have a very precise workflow that takes the digital capture into a CAD drawing for the panels. And yeah. So in this case, we actually built the panels on site using tape measurements, and learned that we can't ever do this again. Like we didn't have enough room to work, and we made a mess of the site. We spent all kinds of money restoring the landscaping. But it actually worked, and the details on the panels actually worked fairly well as well. So we're building a second 2x4 wall that sits on a support beam that we attach to the building, and then we blow that cavity. It's about 8 inches full of cellulose, and we use an exterior vapor open airtight membrane that gets sealed together behind the siding, essentially. So at the foundation, and this is one of the sad lessons that we learned. We dug up down to the footing with a backhoe just as the frost was coming out of the ground, and really made a mess. We had more dirt than you can imagine piled, in somebody's yard, and then some. And so we're now pricing the option of using a hydrovac truck to suck a trench of about 8 inches, and then we can drop a 5-inch panel of carbon impregnated or graphite impregnated EPS insulation, we're pretty confident that ultimately that will be a less expensive version, and that's one of the things that we're working through at the moment. So then we had a big exciting day when we swung the panels in place, which would be, we've actually got some nice video of this as well. We did this in 2 lifts. We did the lower level, then filled that with cellulose, and then did the second level after that. And we didn't have any room for the panels, so we ended up having to actually do that lower level first because we had no place to build any more panels by then. Then we did the second panels. In the lower panels we didn't put siding on, but we knew we had to try it with the siding on. And as I say, all this stuff is working. I think the details are relatively sound. We just need to figure out how to do it way faster and more efficiently. And we have a list of, no kidding, 200 things that we can potentially improve, do differently, that we need to work through to make this go a lot faster and a lot cheaper. And I'll talk about costs a little bit in a bit. But that's our basic section. We've added the insulated wall with the windows installed, the doors, and some siding. Then blew the cavity full from above, and then zipped it together. And for the roof, we essentially cut off the overhang and on the existing roof, and then built an entirely new roof over top. We've sealed the top with just a simple poly vapor barrier. Stuart did lots of calculations to see that would be safe, because we've got kind of a double vapor barrier. We've got the original vapor barrier in the ceiling, and then we've got a new vapor barrier over the old shingles. And one of the points to all this is to do as little to the existing building as possible. You don't want to rip off the siding. You don't want to rip off the shingles. You want to really spare yourself those expenses in labor and disposal. And so that then once the panels are on, we knit the air barrier together, sealing it with very robust tape. You can see those little upside down, or those little U's, those are sealing holes that we left to make sure that we could get cellulose under the windows. So and basically in the basement we're sealed to the foundation. We haven't air tested this yet. We air tested before we started. These are very leaky buildings, 6 air changes an hour and 7 air changes an hour. So we're aiming to reduce that to about 1/10 of that. And the windows have been set back into the wall, sort of passive house style, to try and reduce the thermal bridging, and also to keep the glass warmer so that we minimize the risk of condensation, because the window well is so deep. And because we've sealed the houses up, we have to install HRVs in all of the units. The plan mechanically is to replace the furnaces as well, but that's turning out to be a challenge that we're also working on right now. These units have 60 amp service, and we need at least 100 amp service to put in air source heat pumps. And so we're busy working on a feasibility study to essentially upgrade the services to most of the units. And so this is a before and after kind of thing. I won't read that to you. I just got my 5-minute sign flashed at me here. But I mean, in a nutshell, the big numbers. We're going from like a nominal R15 to about an R41. In the attic, from 28 to about 78. So these are kind of net zero numbers. So there's a whole new kind of beast, these panelized deep energy retrofits. It's not new construction, and it's not a typical renovation. In a typical renovation, you kind of work to what's there. You measure the building, and you kind of do it one piece at a time. We've got to be kind of cabinet precise almost. And it's not even like building a new building from a set of plans where, if you put that window 2 inches away from where it's supposed to be, well, chances are nobody will notice. And here, it's got to fit. The tolerances, especially on the doors, are really pretty tight. We can only buy standard size doors. And as I mentioned, screw that up, and all the advantages are out the window. And so we have to do it really economically. So the cost for our pilot, which is a duplex, is about $120,000 a unit. For us to go through with the other 57 units, we've got to get that cost down to about 85. And so we get a geometry advantage because we've got only one party wall in that duplex, where the other buildings are much bigger, and there's lots more party walls and less outside wall. That'll get us about 1/3 of that reduction. The rest we've got to get on bulk buying and economies of scale and efficiencies for my 200 item list. And it's a very interactive thing. We're working with our workers and trades to try and drive this down. So for this to be affordable, we've got to be supremely efficient. And we really feel like there's a lot riding on it. We have to figure this out. Like, there's a lot of people paying attention. This is the first implementation of Energiesprong in North America. We just cannot fail. And to do it, we have to get kind of Japanese factory efficiency, not only in building the panels, but also in dealing with the site conditions, the 3-generation peonies, whatever, all of that kind of stuff. And so we're really looking for kind of elite kind of samurai kind of trades to make this work. And so one of the things that we're learning, and I learned this in Holland in my trip too, that it's not just a technical problem. Like building consensus, this is a co-op, it's very democratic, convincing people to do this and take the long view. These guys do have a long view, but learning to work with individuals and their foibles and their, like I've built custom houses forever. I'm used to this, but now we've got over 100 people that we're working for. And it's some are into it, some are not. And at the end of the day, we have to make their lives better for this to work. And I think these will be warmer, more comfortable, and more beautiful. They've got nice deep window sills. We're putting skylights in the porches. We're doing these box bay windows. They're a lot brighter and more comfortable and just cheerier than they were. And we've got to make them look better on the outside too. That's another challenge. So this is what it looks like with our pilot projects so far. So part of our commitment to Enercan was not only to do this, but also to talk about it and to do what they call information dissemination. And so we're starting a nonprofit called Retrofit Canada to host deep energy retrofit examples and information and act as an advocacy group. I mean, this is a tall order, an ambitious project, but we just don't see any way for that not to be. That's to fulfill somewhat the role that Energiesprong fulfilled in Holland, but without the generous funding of the Dutch government. So we're just in the process of forming this. Our website went live today. There's not much on it, but it's coming. Yeah, and so and the other thing that I really wanted to do, just while I've got the microphone, is just say how pleased and proud I am to be working with Dave and Annerly Butterwick and Stuart Fix in this new partnership called Butterwick Projects that is the contractor on this project. And we're also working on other multifamily projects and in the sort of early planning stage. And our goal is to build nothing but carbon neutral ready buildings and build them better and faster and smarter than anyone else.